Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bengaluru. The Network and Cybersecurity subject code is 17EC835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept. Module 1 is transport level security. In that we are going to discuss web security consideration, secure socket layer, transport layer security, HTTPS and secure shell protocols. First, considering the web security consideration, in that we are going to study web security threat and different web traffic security approaches. In secure socket layer, we are going to study the secure socket layer architecture, secure socket layer protocol stack and secure socket layer record protocol operation. Then we are going to study the chain cipherspec protocol, alert protocol and handshake protocol operations. In transport layer security, we are going to study the hash function and some cryptographic function. Next, hypertext transfer protocol for secure. In that we are going to study the connection initiation and connection closure operation. Next, secure shell is called as SSH. In that we are going to study SSH protocol stack. Considering secure circuit layer record protocol. The secure circuit layer record protocol provides 2 services for secure circuit layer connections. First one is confidentiality and message integrity. Concerning the confidentiality, the handshake protocol defines a shared secret key that is used for conventional encryption for secure socket layer protocol. Here, shared secret key is used for the encryption for the data. Next, message integrity. The handshake protocol defines a shared secret key that is used to form a message authentication code. You can call it as MAC. Here, the handshake protocols provides shared secret key for both the confidentiality and message integrity. So in the confidentiality, the shared secret key is used for encryption purpose. Then in the message integrity, the shared secret key is used for authentication code. The secure circuit layer record protocol operation. First, considering the application data. We want to consider the application data. Consider the application data that we are going to convert into the fragment. Fragment is nothing but the large data we are going to make it into the equal pieces. Then after fragmentation, we are going to convert each block into compress. So compression means reducing the memory size or reducing the data size. Then we are going to add the message authentication code for that. Afterwards, we are going to do encryption. Encryption is happened. Here for that encryption we are going to use shared secret key. Then afterwards append the secure socket layer record header. The header part we have discussed that. So it's having the content type, major version and minor version. So that header part we are going to append at the last stage. So you need to understand that the large data, consider the example if we are considering the 100 bytes. That 100 bytes we cannot compress, we cannot process it. For that, we are going to make it a fragments, so that we are going to consider 33 bytes, 33 bytes, and 33 bytes. So like that, we are going to make a equal grouping. Then that fragment we are going to compress it. So compress means, suppose if the size is 33 bytes, we are going to make it compress into 25 bytes. We are going to use zip algorithm to compress the data. Afterwards, after compression, add the message authentication code. Message authentication, we are going to add it into that particular part. Then we are going to encrypt the information. Encrypt is converting the information into other form, converting a plain text into ciphertext. Afterwards, we are going to add the SSL record header. The overall operation of record protocol is fragmentation. Each upper layer message fragmented into blocks of 214 bytes, or you can consider 16,384 bytes or less. After the fragmentation, we are going to do compression. Compression is optionally applied. Compression must be lossless and may not increase the content length by more than 1024 bytes. Next is add MAC. MAC is nothing but message authentication code. MAC calculated over the compressed data by the following expression. The expression is, so considering the hash function, hash MAC write secret, message authentication code write secret, concatenate with the pad 2, concatenate with the hash of MAC write secret, concatenate with the pad 1, sequence number, concatenate with SSL. SSL compressed type, concatenate with the SSL compressed length, and concatenate with the SSL compressed fragment. Here we have to consider that compressed type, compressed length, and compressed fragment. Then the sequence number we are going to consider for the hash function. Message authentication code write secret. So for that, we are going to consider the hash function, the sequence number, compressed type, compressed length, and compressed fragment. The final step of secure circuit layer protocol processing is to prepare. Header consists of the following fields. First one is content type, which is having 8-bit size. Second one is major version, is having 8-bit size. Minor version is also having 8-bit size, and compressed length is 16-bit size. First one, content type. The higher layer protocol used to process the fragment. Here the main content we are going to make it into piece of the data that we are going to consider as a fragment. Next is the major version, indicates the major version of secure circuit layer used. That value is considered as 3. The minor version indicates the minor version in use. So for secure circuit layer version 3, the value is 0. Here the major version considers a value 3 and minor version is value 0. Next, compressed length 16 bit, the length in bytes of the fragment.